Welcome. This is the second in a series of videos demonstrating the use of two software packages, pfodDesigner and pfodApp. Now before I go any further, I'd like to point out that in this video and future videos I'm going to be using two methods for navigating the screen. One is the mouse here, and the other one is going to be a pointer, stylus, which I use to click on my files right now. And you can see a little spot appear there. Now when we did the first video, the pfodDesigner file got sent to a folder called pfodApp raw data. And here it is right here. So we'll open it up. And you can see this is just a text file. So what we're going to do with this text file now is I'm just going to have it sent by Bluetooth over to my laptop. And you probably heard the little bell there go ding ding. Well, we'll go over to the laptop now and we'll carry on. So here we can see our pfodDesigner v3 text file that was sent over via Bluetooth. I'm just going to go ahead and open this text file. Just select Edit and select All. Edit Copy. And then I'm going to go straight to our Arduino. I've already got the IDE open, and I've renamed it to a new file here called pfodDesigner video. Just going to go ahead and delete these two here because they already exist in the other file that we're going to paste in here. So we'll do paste, and that's the file that we've created in pfodDesigner. So I'm going to go ahead and do an upload now, and it's going to take a few seconds compile everything. And the reason I'm doing this is just to show what the menu is going to look like on the tablet prior to us making any changes to the software. We'll come back in a minute or two and we'll make some changes to the code to get the program to work the way we want. So as soon as it's done uploading, we can stop the video for a second and jump back over to the tablet. It's a pretty small sketch, so it shouldn't take too long. Okay, done uploading. Okay, we're now back at the tablet. Now I'm going to load pfodApp. Now you can see the program that we created in pfodDesigner 1 and we exported without any changes to the code. And if I happen to click on increment count by 1 here, re-0 at 5, nothing happens. That's because we haven't done anything to the code yet. But as you can see, that's what we've got for a menu that we created. So let's go back to the laptop and let's make some changes to the code. Okay, so now we're back at the laptop and we can see this here A command, increment count by 1. This is for the button that we created to increment the count by 1 and re-0 at 5. And you can see here where it says add your action code for this button. Now I've got a little snippet of code here that I've already written just to save time, but I'm going to paste it in there. And I'm going to have to line it up in the right spot, make it look nice and neat. And I've also got this one added here, send main menu update. Now we'll get into this a little bit further in future videos, but basically the send main menu update is going to update the variable count, which is this command B variable, which was automatically created by the program when it generated this here file automatically. So we don't need the parser.printf anymore. We're just going to comment it out here with a couple forward slashes. Basically what send main menu update does, it tells the program to update that variable every time we click that button. So now we're going to download this, or upload it I should say. Uploading. Done uploading. Okay, let's halt and go back to the tablet. So we're back at the tablet and we're going to see the changes that we made to the code, see how they work. So we'll load pfodApp. Increment count by 1, re-0 at 5. Once we exceed 5, it should go back to 0. So now we'll go back to the laptop and we'll make some more changes and see how they look. So we're back now to the laptop, and as you can see that code we entered worked just fine. Now I'd like to talk a little bit about the data variable range right now that we referred to in the very first video. These two numbers here represent the data variable range. These two numbers represent the scale on the display. Now what you do for data variable range is you put in a value that's equivalent to the resolution of the instrument that's sending you the signal. Let me explain that a bit further. Let's suppose we've got a transducer that can give us 50 counts, 0 to 50, over a range of 5 volts. So it'll be like 0.1 volts, 0.2 volts, 0.3, etc., etc. So what we do is we put 50 in here. And as we do that, we also have to change this value here to 50. Now, what we're going to do is also show that you do not have to go back to the pfodDesigner every time you want to make changes to, say, your graphics. What you do is you just can edit these values here, like count. Let's make this into volts. And the units here, hours, let's change it to just V for volts. Okay, we'll upload these changes and we'll go back to the tablet. Okay, we're back at the tablet. Now the first thing I'm going to point out here on this software is when you make changes to the graphics, like the data display, we changed it. And you don't see it come up here as volts and whatnot because this program retains what's called a cache of the data or the display, the menu that's shown. And what we need to do every time we make changes to that menu, in terms of the graphics, not the program itself, like your commands 0.1, 0.2, whatever, but every time we make changes to the graphics, we need to go ahead and we need to do a clear menu cache. And we do that just like this. And the reason that the program saves that information in a cache is when you've got a large amount of graphics that's shown on a display, the first time you load it, it takes a bit of time. Maybe 10-15 seconds depending on the size of the graphics display. But the next time you load it, it'll only take a second or two because it keeps it in a cache. So when you make changes to the graphics, you've got to go clear menu cache. And now we'll see what it looks like. Okay, that's what we made changes. Volts 0.0. Now we're going to see here every time we increment, we're going to have 0.1, 0.2, 0.3, and we'd have to do this 50 times in order to get up to 5 and have it re-zero. So that's what that data range is all about. Okay, we'll go back to the laptop again. Okay, back at the laptop one more time. Now, a little bit further on this data variable range. Let's say we're using an Arduino with a 10-bit converter. Well, what we're going to do is a 10-bit converter will give you 1023 counts over a range of this transducer 0 to 5 volts. So we'll change that to 1023. And at the same time, we're going to change this to 1023. So basically, every time we increase the value by a count of 1, we're not going to get much of an increase on the volts on our display. In this case, almost 5 millivolts per count. So now we'll go ahead and do our upload again, and this time I won't even bother showing the upload. We'll just go straight to the tablet. Okay, we're back at the tablet for the ending sequence of this video. So I'm going to load pfodApp. Now what I've done is I've done a clear menu cache prior to loading at this time, just to save time again. But we can see if we increment by 1, there's our almost 5 millivolts. If you do the math on it, 5 volts divided by 1023 counts gives you 4.88 millivolts per count. So I hope that explains to a certain extent how that data variable range works. It's one of the harder concepts to grasp when you're first learning pfodDesigner, and we'll be discussing it more in future videos. But for now, we're just going to exit, and that'll be it until the next video.